Hey y'all, Data Guy here. And today I have a video for you that I know is another viewer request. And that is, what is data modeling? How do you do it? What are some systems? What are some examples? And why do you want to use data modeling? And you'll come to find out that data modeling is really just kind of at the core of whatever database you're using. And we also have a guest appearance from the Data Dog here today because he is being a little rascal. Um, but back to the regularly scheduled content. So data modeling is really defining the structure for your database. So imagine, whenever you're trying to put just raw data that you're extracting from, an API, maybe just information about your sales, it typically is coming in a pretty messy way. It'll just be, raw machine data that just says, hey, this is some string of numbers and letters that represents the transaction, your hashed credit card ID, purchase amount, customer name, things like that, and bringing that into your database and saying, hey, I actually want to align that based on which customer bought this. I want to maybe add that to a database I have of existing customer orders. You're going to need to have a model to define how are you joining that data into your existing database. Um, and so that is what data modeling is. And so I have up here an example kind of a relatively simple data model. And just to kind of walk you through an example of, hey, how does this work? And, what is the initial type of data modeling? Before I do that, so I just high level, data modeling is, really it's the art and kind of the science of framing data in a manner that makes sense, but it also can be easily manipulated and analyzed. So it's not just for making this human readable. It's also making sure that your queries are really efficient, so that you can save money on the compute needed to actually run those queries to access the information you need when you're doing large scale analytics. And the costs of going through millions and millions of lines of data can become quite significant. Um, so this provides, foundation for by having cleanly ordered data that's easily queryable. You can really provide a solid foundation for many different applications, like database design, machine learning algorithms, bringing your data directly from here, into some kind of analytics platform. It just makes everything you're doing on top of the data much easier if you have a very clean and structured data model. And so you can kind of see here within this, it is really a conceptual representation of data objects. So, obviously this is, these are going to be different tables within a database, but at a high level, you're going to want to, kind of diagram it out to make sure, hey, do these relationships between, payments being linked to the order object makes sense? And is that like logically where I'm typically going to get the payment information from by querying that order header? Or maybe it should be under customer because, I want to look at all the customer's payment information. And so that's kind of a choice, this user has made where they have payments being linked directly to order header rather than by customer. But there is the customer ID within the payment object. And so you're looking at not only the representation of the data objects, the relationships between them, the rules governing these relationships. So you don't the rule that, hey, maybe in this you never put payment information in the customer object. And it's really just a blueprint for as you build and ingest data, guiding the structure of the data in kind of a systematic and standardized way. So just to kind of walk you through what this data model is here, so then I can talk about maybe some of the example applications and why it's useful. So here we have, the base object or maybe your, order header. So every time, customer makes an order, there's an order header, which has an order ID, order date, order time, customer ID, which links to the customer and all the information about them that they purchased this for. It also has a linkage to the delivery ID. And so it's actually not the delivery ID references the order ID. So order ID doesn't reference the delivery ID because typically if we're looking at delivery information, we're not, or we're just going to need the order ID from there. But if we're looking at the order header information, we're not going to typically need the delivery information because maybe we're just looking at the payment. And this is one of those decisions that, hey, I didn't make it, but someone made this decision to say, we don't actually need delivery ID in order header to save space on storing that twice. Because some of these fields like customer ID here under payment, and in here you have PK. So within each table, you'll have a primary key. And what that is the totally unique identifier for each object. So there can be no duplicate customer IDs within this table. And the primary key here is how you can reference this table. So here, customer ID referencing customer here. But this is basically your single source of truth that, hey, every customer is going to have a unique ID. Every payment's going to have a unique ID there and a primary key. Every order ID is going to be unique. And maybe, two people made the same order on the same time, but they're going to be distinguished by their different order IDs. Even if a customer made an order twice, maybe they fat fingered, clicked it twice, they're still going to have two separate order IDs to differentiate them. And then we here under order line, you have primary key, line ID, which is a foreign key. So this means it matches a primary or alternate key inherited from another table. So this means that this key isn't actually present in all of this information. So this is being pulled in from a line information. Maybe that's the head database where it actually just stores all the different orders separately. And so that's if you need to bring information from a separate database, you can use foreign keys that will match another unique identifier. So the line ID will have to be unique in another table that this is pulling from. Then over here, you have the product ID with the product unique identifier name and specification, because that's all the information you need about a product, because many people are going to be buying it, many people are going to be referencing it. So you don't need a lot of unique information there, other than each product is obviously its own type. And so that was actually only one type of data model. That was the relational model. So with the relational model, it is you have concept of relations, which are represented by different tables. And so tables are used to store data, establish the relationships between those different data elements. So by primary key referencing each other. And it's widely used because it's relatively simple to set up. It has really powerful query abilities as well. You also have object-oriented data models. And so object-oriented data models combine data and the operations that can be formed on data, like extracting into a model. And so this is really useful in applications where you need, real-world representation of your data with complex relationships and operations, where you have, maybe not a large amount of objects, but each of those objects has to store a lot of different state changes. Maybe it represents, maybe an AI model that has, actually, no, that wouldn't make any sense. Sorry. Maybe it represents like the ingestion of or the robotics of a car factory robot. And all the tons of crazy information about all the different operations it's performing. You also have network data models. And so these kind of are an extension of this hierarchical data models, which are basically just a tree-like structure. So you can see here, kind of looks like a tree. Each record has a single parent and zero or several children. And this is kind of an earlier database system where you didn't really have a lot of data. So, you'd have like, hey, this company has this many users, and then you kind of have, like almost like a leadership chart of each manager has this several people under it, but it really has limitations when, you want to represent many relationships, maybe the relationships between, using that kind of worker analogy, like relationships between coworkers, you couldn't do that. It'd have to go through their manager. And so that's where you had the network model come in, where you have multiple parent records for each child. So you can have, one child is linked to many different parents, and that kind of allows you to represent more complex relationships and, kind of work around the limitations of the hierarchical data model, but wouldn't say it's super popular these days. Then there's also the entity relationship model, which is widely used in database design. And that's where you have entities, attributes, relationships amongst entities, helping you to kind of have a really clear, logical view of the data. So here you have kind of an example of that, where it is, almost just like a mapping of relationships between things. So here you have an address, name, affiliation for like a bank branch. You have withdrawals, account number, balance, deposits, which also inherits from account balance. And this is, great for when you just have a lot of different things that all relate to each other. So maybe not a lot, but a relatively small amount of things that have really defined relationships that you are going to happen. So you're always going to have to go to deposit or draw from a bank. It's always going to be a user that does that, and just having that very clear model to understand how your data is flowing makes it easy to process, collect, and then query down the road. So really just easy to look at when you compare it to maybe something like that. Relational data model, where it does take a little bit of kind of thought, conceptualization to really get them. And so those are kind of like all of the different, actual data models, in terms of implementing. There's also things like conceptual and logical data models that are just high level representations of your data, but that's not really what you'll be using in practice if you're implementing data modeling, unless you're just visualizing it to an external stakeholder. So some of the applications of data modeling, kind of moving on now. And so now to kind of bring it all together, how is data modeling used in the real world? So there's the conceptual data model right at the top, and that's really just the business view of understanding, how data is flowing through your business, how it's going from, your front end applications, whether you're, a bank or an application, and you like someone like Facebook collecting information about their users, understanding how that information is collected, stored, and then used. So it helps you, so some of the benefits of this, you have database design, helps you to identify the right data structure, understand, hey, this is the type of data we're collecting, these are the types of things we want to do with it. And so data modeling allows you to define the relationships of, hey, how are we bringing it from that raw data into usable data that then can be easily used by our developers. So that's kind of the architect's job, figuring that out. And then this ensures, obviously data integrity and accuracy. Make sure that if we're doing things like AI, ML, that we're actually training our model on relevant data and not just completely screwing it up and setting ourselves up for failure by making inaccurate predictions. And kind of hand in glove with this, you have data analysis. You have bringing your data from its backend databases into BI or analytical applications for people to actually gain insights from all the data that you're painstakingly modeling all day. It doesn't mean anything if no one's actually using it for anything. And so this data modeling provides a clear structure for analyzing that data and aiding you in making easier and better decisions. You also have application development. So understanding, hey, how is our data going to be used in applications? So you can look at, your transaction operation applications, management of that, understanding, how you're storing your transactional information, to kind of use the example here, and ensures that the data that you're handling from your applications is accurate and consistent. So you're not storing inaccurate data around, your purchasing patterns, so that you're then, not misled about what your customers are actually buying. And then also at kind of the more, I guess, boring level, provides data governance. So gives you a common vocabulary, clear understanding of, hey, this is where all of our data is stored, by having that mapping out of, hey, this is where all of our data is, what types of data we're storing, where it's stored, what, security measures are taken on that data. And that can also help you in compliance with any kind of standards and regulations. And obviously for any kind of financial institution, that's really crucial. Or any compliant or GDPR compliant organization as well. Because the Europeans love protecting personal data, which is awesome. And so to kind of like guide you through a typical workflow you're going to be going through when you're establishing data modeling, number one, conceptual modeling, which is just really getting the high level insight of what is the data we're working with, what do we want to do with it, what do we need to store, what can we prune maybe as we ingest it, what do our end business user stakeholders, so the executives, need to see in their analysis or in their reports, making sure that that data is stored properly, collected properly, and defining how it's going to be used for our analytics engineers or just analytics data scientists to actually produce those reports easily, without them needing to constantly come to us and ask us, oh, actually, we need to change this and do that and blah, 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 blah. So this also involves conceptual data modeling. So, as I said, high level representation based on those stakeholder requirements, not really very technical, more something that you'll want to present to someone that doesn't really understand databases but understands what that data needs to be used for. Then after you've gotten all that set up, you'll then want to go into the logical data modeling section and develop a really detailed technical model that includes your attributes, primary keys, foreign keys, relationships between different tables, and just really map it all out in actual technical detail. And also understanding, hey, what is the kind of data we're ingesting? What are the attributes of that data? And really just set yourself up for success when you actually start ingesting it. And when you're going to start ingesting it and actually build your database is in the physical modeling stage. So you're not actually going to build a database from scratch. It's not hardware, but you are going to be creating your database schema based on that logical model. So designing, schema and all the different relationships between those databases, and then optimize, for performance, indexing, partitioning, maybe sharding in different databases, whatever you need to do there, do it before you actually start ingesting the data, so you don't have to move around data after. And then finally, you'll actually create the database and start uploading your business data. But then the kind of hidden fifth step is maintenance. So you're going to have to deal with things like data change capture over time, and maybe sometimes, hey, executive says I actually need to get this pie graph up. You'll have to go there and change your data model to actually reflect that. So you're going to need to make sure you document everything, make sure everything is human readable, legible, that you can go back and make any changes easily rather than having to, comb through spaghetti code and technical debt. And so because data modeling, it's obviously you're not going to take your data model and just like paste it into a database. You're going to just use a data modeling tool really to kind of visualize. So any design tool that you're already using, you can probably use for data modeling, but there are also some dedicated tools for this. So the most popular one is ER Studio, and this actually lets you plug into your databases and kind of identify them, identify relationships between your data, but it also allows you to design yourself within your data modeling tool. You also have DB schema, so schema documentation, monitoring, scaling schemas on relational and NoSQL databases. You can quickly, copy and paste complex schemas for if you want to replicate a database from one to another. You also have Irwin data modeling. So this is creating a database from a physical model and actually does allow you to interpret, what your specifications were and create a database. So kind of remove some of the steps. I mean, you still have to write out all the different steps in your physical model, but instead of just kind of doing the double work, you can, if you do it right, format in Irwin initially, it'll automatically apply it and build that database if it's compatible, of course. You also have Archie, which is cheap solution, allows you to just visualize and describe architecture. So just pure visualization tool, SQL database modeler, and this is again you can build a model within see it within SQL database modeler and then use it to build a corresponding SQL database. You also have Oracle SQL Data Modeler if you're still using Oracle databases. And then IBM InfoSphere Data Architect, which is really built for business intelligence and statistics. So really good for if you're not super data engineering focused and you just want to say, hey, how are we ingesting data and then bringing them into our analytics platforms. MySQL Workbench, so just nice open source figure, allows you to construct models for MySQL. However, I hate working with MySQL, so I'm not even going to touch that. Lucidchart, this is just nice collaborative online tools. So if you're working with many different people, you have a large team. There's a lot of different features that you can use within Lucidchart, and it's all cloud-based, so you guys can collaborate on your models together. And then you also have PG Modeler, which is another open source tool, so got to have work the open source tools in, that has complete access to its source code, and it's just super easy way to write a model for PG or for PG SQL, PostgreSQL databases. And yeah, so that's kind of all I have for you today. I just really wanted to go into kind of everything around data modeling per that viewer request and just talk about it because data modeling is really indispensable in the modern world. It's the bedrock upon all of your data, all of even data quality is built on top of data models, allows you to do actual insightful analytics, effective use of data in your applications, and just really brings a lot of clarity and organization to data management. So can really be valuable in a ton of different sectors. And I hope that you found this video helpful for identifying what you want to do for a data modeling strategy. And so Data Guy signing off. And if you have any ideas for future videos, any other topics you want to see explained, drop them in the comments below and I'll get to it. Peace. Data Guy out.